Alright, we're going to show a randomly generated set of numbers between 0 and 1. And we're going to get the mean of it. And this is for probability. We're going to get the mean, standard deviation, and probability. Did I just say probability? Yes, I did. I said probability. Here's the function. Here's the program for it. It's pretty long. Made this in 2007, or I made it with my teammates. Basically, it's a simulation problem for a uniform distribution between 0 and 1, or any integer range you could figure out. 1 to 4, 1 to 3, 2 to 4. We pick 0 to 1 because that's a uniform distribution. Here it goes. Run silent is 10,000 items that we gonna step through a for loop, and 0, these are arguments to run silent. 0 is the range for the probability range, not probability, but the range for the uniform distribution, 0 to 1, and 4 is the decimal places, which is just going to be our scaling factor. It's kind of hard to explain, but when we run rand, let's step back here. This is a probability called P, and we're running it so that it can have private data for that specific class, like A, B, X, decimal size, num items, da 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 da. It has access to these functions called run basic, display xi's array, get mean, get mean. Alright, and then what we're trying to prove here is a collection of means it's going to have a different standard deviation once we limit it to a sample size of 500. See, p.getMean is a mean of a mean out of a 10,000 item collection. So, and then we start another instance of a probability class called Q, and we insert it into its list, which is ADT, type of doubles. See there? Type def, double, list, item type, ADT. Alright, this is getting kind of confusing. So we run Q run all, and that basically generate random data is what generates a 10,000 item list. Right here. You run srand. Oh no, if it's empty, the list is empty, you run srand, but here's the meat and bulk of it. Temp equals item type rand modulus b plus a. We get this range by subtracting b from a, and we multiply a times int, which is 10,000, and multiply b times 10,000. Whoopsie. Undo. And we'll just run it to show what's going on. Here we go. You will see something very interesting if you like numbers. If you don't like numbers, you better turn away. It can be quite abstract if you've never taken probability and stats. See that? It's 500 list item. The first block of this statement pertains to a distribution of 0 to 1 out of 10,000 items, randomly generated items. So the probability that it lands somewhere between 0.4 and 0.7 is 28%. And the mean of the 10,000 item list is 0.4669, and the mean of the second block here that starts with probability 1, it says 0.4696. That's the mean of the 500 item list, which is displayed by these data points in xi's array. And as you can see, the standard deviation is a little less because it's more tighter, it's more accurate, it's closer, it's more precise, because they're a collection of means. So if you think about a distribution from